Assalamu alaikum and good evening, everyone. Today we are going to start October-November 2023, paper 1-1. Okay. So let's start with question number 1. Sodium azide, NaNa3, is an explosive used to inflate airbags in cars when they crash. Okay. It consists of positive sodium ions and negative azide ions. Okay. So if you see, this is a sodium ion, then the azide ion must be N3 with the -1 charge. What are the numbers of electrons present in sodium ion and azide ion? So for a sodium, it's the atomic number of sodium is 11. So when it becomes a positively charged, it means it has a 10 electrons. So which makes A and B wrong, correct, and C and D wrong. Now, if you recall nitrogen's atomic number is 14. No, nitrogen's atomic weight is for atomic mass is 14. Nitrogen's atomic number is 7. So it means it has a 7 protons, right? And 7 electrons as well. So if I say N3, so it means 7 times 3. So how many electrons it has? 21. And it has a 1 minus charge, right? Which means 1 more electron. So 21 plus 1. So it goes 22 electron. Is this understandable to all of you? So this makes B correct and A wrong. So A is the wrong answer and B is the correct answer. I hope it's understandable to all of you. Now, question number 2. The graph shows the variation of the first ionization energy with proton numbers for some elements. The letters used are not the actual symbols of the elements. Okay. Which statement about the elements is correct? Okay, so if you see, okay, P and X are in the same period in the periodic table. No, this drop is actually showing change in period. This bigger drop in energy is showing that there is a change in shell, so the change in period. Okay, I don't know, the screen is again stuck. Yeah, so it's change in period. Okay, and Shura, let me see. So this goes wrong. The general increase from Q to X is due to the increase in atomic radius. No, if you see there are 2 drops, so it's due to the ionization energies, not atomic radius. So A and B goes wrong. The small decrease from R to S is due to the decreased shielding. No, if the ionization energy decreasing, so it means it is in not decreased, increased shielding. So C goes wrong. The small decrease from U to V is due to the repulsion between paired electrons. Yes, it's the answer that in V, it has a more number of, it has a electron in the one pair of electron in the P subshell, and in U there is no paired electron over there. So that's why V has a lower ionization energy. Very good, Anshura. So D is the correct answer. Okay. Now question number 3. Aluminium carbide Al4C3 reacts readily with aqueous sodium hydroxide. The 2 products of the reaction are NaAlO2 and a hydrocarbon. Water molecules are also involved as a reactants. What is the formula of the hydrocarbon? Okay. Aluminium carbide Al4C3 reacts readily with sodium hydroxide. The 2 products are formed. One is NaAlO2. Okay. So from this and a hydrocarbon. Okay. From this, I can say that there must be 4 moles of NaAlO2, right? And if there are 4 moles of NaOO2 because of this, so here I'm going to get 4. So sodiums are balanced. So 4 times aqueous sodium hydroxide. So it means it is also the reaction is with water as well. It's an aqueous, right? Water molecules are also involved as a reactant, so water can be there as well. So, okay. Guys, just give me a minute, please. Okay. So, due to 4 aluminium, I put a 4 before NaAlO2. So 4 sodium hydro are there. Now, if you see that by putting this 4, this oxygen would be 8. And over here, how many oxygens we have? 4, right? So it means that to balance the equation, we need 4 more oxygens. So to need 4 more oxygens, I will put 4 over here. And if I'll put 4 over here, then if we'll see, now let's have a look. Sodium are balanced on both sides. Aluminium are balanced on both sides. Here we got 8 oxygen. 4 are here and 4 are here. So the oxygens are also balanced, right? Now, if you count the hydrogen, there are 4 to the 8 hydrogen and 4 ones are 4. So how many hydrogens we have? 12 hydrogens. And if you see how many carbons we have? 3 carbons. So C3H12, is this possible? No, not at all, because the general formula is CnH2n plus 2, right? So, but this is a possible if you would put C3H4, isn't it? So the correct answer would be A, B, C, and D are wrong. After balancing the complete equation, you are able to know that with 3 carbons, we are left with the 12 hydrogens. So C3H12 is not possible a compound. C3 with 3 carbons, if there are 3 carbons in the compound, then maximum we have 8 hydrogens with it, but we are getting 12 hydrogens left. So 1 carbon bonds with 4 hydrogen gives you methane. So in this way, there are 3 moles of methane can form. Is this understandable? Okay, Anshara, have a look over here. If anyone else has a confusion, please have a look so you can identify. See, they are saying you have a one compound Al4C3, which reacts readily with sodium hydroxide, right? The two products are of the reaction are NaAlO2, right? And a hydrocarbon. So I'm not, okay, and a hydrocarbon. Water molecules are also involved as a reaction, so I need to put a H2O over here. I hope now it's clear to all of you. Till here, is it clear? Okay. Now start balancing the equation. We have 4 aluminium, so that's why I will put 4 over here. So if I'll put 4 over here, sodium also becomes 4. So for that reason, I will put 4 over here. Is this understandable to all of you? Till here, is this clear? Now think, if there are 4 sodium, then over here, how many oxygens we have? 4. But over here, how many oxygens we have? 8. So to balance the equation, to balance the oxygens, I need to put 4 over here. Is this clear? Now, 4 oxygens over here. So the oxygens are also balanced. So if you see, we are balanced with aluminium, we are balanced with sodium, we are balanced with the oxygen, and we are balanced with, yeah. Now carbon and hydrogen are left, right? If you count the hydrogens, see 4 hydrogen over here and 8 hydrogen over here. So we are left with 12 hydrogens and 3 carbons. So C3H8 is the compound. There is no C3H12 is the compound, is it? So if there are 3 carbons and 4 and 12 hydrogens, so the only possible way is that it is going to be CH4, and there would be 3 moles of CH4, then 3 carbons and 12 hydrogens would be justified. Now, is this understandable to all of you? Okay. Now, question number 4. A sample of 35.6 gram of hydrated sodium carbonate contains, see, it's hydrated, it means it's Na2CO3 dot XH2O or NH2O. We don't know the number of moles of water. 25.84 sodium ions by mass. Okay. What this sample is heated, anhydrous calcium carbonate and water are formed. Which mass of water is given off? Okay. So if is it 25.84% sodium ions by mass, just take the 25.84% of sodium carbonate. Just first find this, that 100% is 35.6. So if it's 25.84, then what would be the mass? Can anyone calculate this mass? And this mass we calculate over here would be the mass of sodium. Yes, can anyone calculate the mass of sodium? It's 9.19. Okay. So 9.199. Okay. Now see, if we just ignore water and we think of sodium carbonate only, so its MR is 106, and there is 46.2 gram of sodium, if I'm not wrong, because see, no, it's 20. Yeah, it's 23 sodium. So 46 gram of sodium. So if 46 is sodium, then it means this must be 50. 3 oxygens is 48. This must be 60 gram. So see, we got the ratio that with the in sodium carbonate with the 46 gram, there is 60 gram of carbonate, right? So if the sodium mass is 9.199, then what would be the mass of carbonate? Let's make it Y. So calculate the value of Y. So Y is going to be 9.199 times 60 over 46. Can anyone calculate the value? So we are able to calculate the carbonate mass as well. So see, in 35.6 gram is Na2CO3 dot XH2O. Out of this, sodium is 9.199 grams. Carbonate is, we have just found 11.99. Thank you, Hassan. So what mass is left? So the mass of water is equals to 35.6 minus 9.199 plus 11.99. Can anyone calculate it and tell me the answer? It's 14.41. So which means it's C. So A, B, and D goes wrong and C is the correct answer. Is this clear? Okay. Now question number 5. Solid aluminium chloride sublimes at 78 degrees Celsius. What structure best represents the species in the vapor at this temperature? Okay, if it's in the vapor, so it's very simple. It cannot be ions. And in vapors, it is always in the form of, dimer. Okay, no problem, Fiza. And I have uploaded the recording till yesterday, so you guys can watch. So C cannot be an answer. If you see B, here the direction of the dative bond is wrong. So B is also not an answer. So we are left with only A. So A is the correct answer. No, because whenever it forms a covalent compound here, it's an electron deficient, so it doesn't stay as a it turns into its dimer type 2 units where it forms dative bond to complete the octet of aluminium as well. Okay, Anshara? Am I audible now? Okay, now question number 6. Which row is correct? H3O positive. Okay, H3O positive, if you see oxygen with 3 hydrogens, and oxygen has a 1 lone pair as well, because oxygen has a 2 lone pair when it forms a bond. So if it's this, then it means C. It has a 3 bond pair and 1 lone pair. Then its shape would be pyramidal, right? Then the shape would be pyramidal. So A and B is correct, C and D goes wrong. Okay, now SCl2. And if for SCl2, the sulfur has a 2 bond pairs and 2 lone pair as well. So in this way, its shape is bent, which we call it non-linear as well, right? So these two are already goes wrong. Here it says linear, which makes B wrong. So A is the correct answer. Is this clear to all of you? Now question number 7. When evacuated tube of volume 400 centimeter cube is filled with the gas at 300 Kelvin and 101 kilopascal, the mass of tube increased by 0.65 gram. Assume that the gas behaves an ideal gas. What is the identity of gas? So we know the mass, we know the volume, we know the temperature, we know the pressure. Okay, so it means we are going to use this expression PV is equals to nRT. Further, PV is equals to M upon MR RT. And we are going to find the MR to know the identity of gas. So MR is equals to MRT over PV. Now, you must remember, mass we always take over here in the grams. R is the constant 8.31 joules per Kelvin per mole. Temperature must be taken in Kelvin, pressure must be taken in pascals, and volume must be taken in meter cube. So it is in Kelvin, that's fine. It's in kilopascal, so we have to, multiply it with 1000 to turn into kilopascals. It is in centimeter cube. So I have to divide it with exponent 6 to convert it into meter cube. Okay, now let's put the values. M is 0.65 times 8.31. It's, I think, 8.31 or 8.13. I always, got confused. Yeah, it's 8.31. Times temperature is 300 Kelvin divided by 101,000 pascals times volume, which is 400 over exponent 6. So can anyone solve it and tell me the answer, please? What answer we are getting? $40.1. Thank you, Hassan. So if we see 40.1, okay, so 39.1 is potassium, calcium, and argon. Now think, argon is the gas and potassium and sodium are the metals which are solid. So over here, okay, so it's not helium. It's neither krypton, it's neither neon. So the closest is with the 40 is argon. So A is the correct answer. Is this understandable? Now question number 8. Nitrogen N2 and carbon monoxide CO both have a MR of 28. The boiling point is 77 Kelvin and 82 Kelvin. Okay. What could be the responsible for the difference in boiling point? CO2 molecules have a permanent dipole. Yes, this is correct. And N2 molecules are not polar. Yes, this is also correct. And that's why there is a difference in the boiling point. That is the correct thing. Nitrogen has a sigma and pi bonding. Carbon monoxide has a pi bonding, sigma bonding only. So that's completely wrong. Both have a triple bond, right? Nitrogen has a strong triple bond. Carbon monoxide has a double bond. No, wrong. Carbon monoxide also has a triple bond. So B is wrong. C is wrong. The carbon monoxide molecule has more electrons than nitrogen molecule. No, if you count the molecules, they both are isoelectric. They both have the same number of electrons in them. So D is wrong as well. So why? Because then atomic number of nitrogen is 7, right? It's N2. So in N2, as the atomic number is 7, so how many electrons we get? 14 electrons we get. Carbon's atomic number is 6 and oxygen's atomic number is 8. So 6 plus 8, how many electrons we get? 14 electrons we get. So see, both have a same number of electrons. Carbon monoxide doesn't has a more number of electrons. So D goes wrong as well. And A is the correct answer. Now, question number 9. Which statement about enthalpy change is correct? The enthalpy change of reaction are always negative. No, it's delta HR. So it can be any, it can be positive or negative. We don't say. The enthalpy change of combustion are always positive. No, it is always negative. So B is wrong as well. The enthalpy change of formation is always positive. No, formation is the one where the elements turning into a 1 mole of a compound. So we don't know. It can be positive or negative. So C goes wrong as well. So it obviously means that D is the correct answer. The enthalpy change of neutralization is always negative. Yes, someone I think asked me yesterday. So remember, enthalpy change of combustion is always negative. Enthalpy change of neutralization is always negative, right? Okay. Now let's move to question number 10. What is the definition of standard enthalpy change of a neutralization? Enthalpy when 1 mole of an aqueous acid is neutralized by an aqueous alkali. No. 1 mole of aqueous alkali is neutralized, not at all. 1 mole of an aqueous acid is neutralized, again, not at all. When an aqueous acid and aqueous alkali react together to produce 1 mole of water, yes, that is what the definition is. Very good, Fiza. So B is the correct answer for question number 10. Now question number 11. Aqueous HOCl is the molecule that kills bacteria when chlorine is added to water. Okay. The following reaction produces the molecule. Okay. When chlorine is reacting with the water, we are getting HOCl, hydrogen ion, and chloride ion. Which statement about this reaction is correct? Chlorine is both oxidized and reduced. Yes, I think that is correct because that's what we studied in our syllabus, in our lectures as well. See, chlorine is 0. Over here, chlorine is -1, and over here, chlorine is +1. So that is the correct answer. So B, C, and D goes wrong, and A is the correct answer. Okay. Now, question number 12. Nitrogen dioxide NO2 exist in equilibrium with the dinitrogen tetroxide. Okay. Which conditions gives the greatest percentage of N2O4 at equilibrium? So pressure would be high because product side has a lesser number of moles. Increasing pressure shifts the equilibrium towards the side where there are lesser number of moles. So these two goes correct and these two are wrong. Now temperature, it's an exothermic reaction. So remember, temperature increases, shifts equilibrium towards endothermic side, and if we lowers the temperature, shifts equilibrium towards exothermic. Sorry, shifts equilibrium towards exothermic side. So here low temperature would be the correct one and A would be the wrong one because higher temperature will shift the reaction towards backward and then more energy will form. So B is the correct answer over here. Is this understandable to all of you? Now question number 13. When an equimolar mixture of hydrogen and iodine reacts, the mole fraction of hydrogen iodide in the final mixture is X. Okay. So hydrogen and iodine what is the equilibrium constant Kp for this reaction? Okay, so it's a little tricky. So the equation would be like this, right? So um, we are saying that the mole fraction of Hi in the final mixture is X. Okay. So let's suppose this is 1 and this is 1 initially and it's 0. Is this understandable? At equilibrium, this says that it's X, but there are, okay, let's make it X. So if this is X, then isn't it, it is going to be 1 minus half X, and it is going to be 1 minus half X. Is this understandable? because of the mole ratio. That is the mole fraction, not the moles. Okay. So let me do one thing. Okay. At equilibrium, if x moles are decreased over here and x moles are decreased over here, then 2x moles of hydrogen iodide would form. Is this understandable? Because initially the moles we assumed that they are 1. That's why. We assume that it's 1 and it's 1. So at equilibrium, x moles are decreased, and 2x moles are formed. Okay. Now if I have to find the total moles, so the total mole is equals to 2x plus 1 minus x plus 1 minus x. So if you see over here, it's going to be 2x minus 2x plus 2. Okay. Now, if you see, we got the moles and we put it in a Kp expression. The Kp expression would be equals to partial pressure of, let's say, hydrogen iodide square over partial pressure of hydrogen times partial pressure of iodine, right? So it's 2x. So 2x square over 1 minus x times 1 minus x. So if you solve it, what you will get? 4x square over 1 minus x whole square. So 4x square in the numerator. So it is the only one. So A, B, and D goes wrong and C is the correct answer. Let me share it again. Okay, so we are getting this expression which is over here. So C is the correct answer. Now, question number 14. Okay. In reaction 1, a student measures the initial rate of production of carbon dioxide gas when copper carbonate solid is added to a 50 centimeter cube of 0.1 mole nitric acid. Okay. In reaction 2, the student repeats the experiment using 50 centimeter cube of 0.5 mole per dm cube nitric acid and the same mass of calcium carbonate. So see, the concentration is increased. So it means in reaction 2, rate would be higher, right? And in reaction 1, rate would be lower. Is this understandable? So rate of reaction 1 over rate of reaction 2. So obviously the above we have a smaller value and below we have a greater value. So the answer would be lesser than 1 in that case if we put the numerator a smaller value and the denominator a bigger value. For example, 3 over 4, 2 over 4, 1 over 4, 5 over 6, 7 over 8, we always get lesser than 1, right? So that's why A and B goes wrong. Okay. So obviously if in reaction 1 the concentration is lower, right? It's 0.1 and over here it's 0.5. So the initial number of moles would be less in the numerator and the initial number of effective collisions would be more in numerator. So it is also going to be lesser than 1. Yes, right. 1 minute, Hadi. So greater than 1 goes wrong. So lesser than 1. So D is the correct answer. Yes, Hadi, what you are saying? KP. Okay. Are you clear till here? Yes, Hadi. So you just need to put those values in the KP expression and solve it. So you will get this answer. That's it. Okay. Now, question number 15. The forward reaction of a reversible reaction is exothermic. Okay, it means this is exo. So obviously the backward reaction would be endo and has an activation energy of positive 30 kilojoule per mole. So it means that forward reaction is exo, which means if I make the profile diagram, so it would be like this, and this is positive 30 kilojoule per mole. The reverse reaction proceeds by the mechanism that is exact reverse mechanism of the forward reaction. Which statement about the activation energy of the reverse reaction is correct? The activation energy of the reverse reaction is equals to minus 30, not at all, because now for the reverse reaction, the activation energy would be this much, right? From the lowest, from the now these are the reactant. The activation energy of the reverse reaction is greater than 0 kilojoule, but not less than 30 kilojoule, not at all. So if you see over here, this is enthalpy change of the forward reaction. Now, for the activation energy of backward reaction, minus that enthalpy change value, whatever it is, obviously it is in minus. So when we put the sign minus, it would get positive. Wait, Anshara. Why you are saying not 2x? Isn't it's going to be 2x? Because we are when we are taking the ratio, so we assume it 2x, twice of x. That's what. And they have given you the mole fraction is x, not the moles. Okay. So plus 30. That is going to be the activation energy of the backward reaction. So the activation energy of the reverse reaction is equal to positive 30. Not at all. The activation energy of the reverse reaction is greater than positive 30. Yes, this is the correct answer. So D is the correct answer. Is question number 15 is understandable to all of you? No, it's 4x square. It's not 4x only, Anshara. Because see, it's a square, right? So when we put the at equilibrium, these are 2x. So when we square it, isn't it, it goes 4x square? Okay. Let me show you the whole working thing. I don't want to, you know, spend so much time on this, but let's have a look if you guys have done. See, what are these? Tell me what are these values? Yes. Can anyone tell me what are these values? Yeah, these are moles at equilibrium, right? Okay. Now, have a look and try to figure out carefully very Kp is equals to partial pressure of hydrogen iodide square over partial pressure of hydrogen times partial pressure of iodine. Is this clear? Okay. Now, what is the how to calculate the partial pressure? Partial pressure is calculated by total pressure times mole fraction of that gas, right? So actually I skipped so many steps. Now let's have a look. So over here it is going to be, total pressure times for a mole fraction of hydrogen iodide, I am going to put 2x over here over 1 minus x plus 1 minus x plus 2x, because this is going to give me the total moles. Is this understandable? And I am going to take the square of this, because partial pressure of a hydrogen iodide must be squared, right? What you want, what we will multiply? How you calculate the total moles? If you have to find the total moles at equilibrium, will you add the moles or will you multiply the moles, Anshara? Just go through the KP expressions, the videos, if you have any problem in finding the total moles. If you have to find the total moles, you will just add the moles at the equilibrium. You don't multiply the moles at equilibrium. Now, divided by total pressure times, for I'm talking right now doing for hydrogen, times 1 minus x over 1 minus x plus 1 minus x plus 2x. That is for hydrogen. And that same goes with the iodine as well, that the total pressure times 1 minus x, which are the moles of iodine at equilibrium, over 1 minus x plus 1 minus x plus 2x. Till here, is this clear to all of you? Now, see, can't I write this one, that Pt into 2x over 1 minus x plus 1 minus x plus 2x whole square, and in the denominator it also becomes a square, Pt times 1 minus x over 1 minus x plus 1 minus x plus 2x, and isn't going to whole square. Is this understandable? Yes, is it understandable to all of you? If anyone have still any confusion, please ask. Now see, aren't these two going to cancel out, and this whole thing is going to cancel out with this whole thing? So what you are left with? 2x square over 1 minus x whole square. So isn't it going to be 4x square over 1 minus x whole square? Yes, I hope it's clear to all of you. So that's why I skipped all of these values and I just put them in the KP expression and solve it directly initially, okay? Because these are going to be cancelled out at the end. Okay, now question number 16. X, Y, and Z are elements all found within group 13, 14, and 15 of the periodic table. Okay. X is in the same group in the periodic table as Y. Okay, so it means X and Y are in the same group. Y and Z are in period 3. Okay. The first ionization affinity of X is greater than the first ionization energy of Y. So it means that X must be at the top and Y must be at below, and Y and Z has the same rho. The melting point of Z is less than the melting point of Y. Okay. Okay. Y and Z both forms chloride, which are white solids. These white solids react with water to produce the solutions at pH less than 4. Okay. So if the pH is less than 4, so it can be all of them. Yeah. Okay. So Y can be all of them. And if Y is aluminium, see, we have identified whatever Y is, X is at top of the Y. So let's have a look in the periodic table. If Y is silicon, then X must be a carbon. There is no carbon. So this goes wrong. If Y is phosphorus, then X can be a nitrogen. And over here, X is arsenic. So C goes wrong. Okay. And for this, NCl3 is not a solid. If there is a NCl3 would form. We didn't study nitrogen chloride, so that's why D cannot be an answer. And NCl3. Okay. So we are left with only option A. So A goes correct. Another thing, see, they are saying that Z has a lesser melting point than Y. So if we take phosphorus, for example, as you said that if why don't we take D? So if it's a phosphorus, then with phosphorus only this one has a lower melting point than phosphorus, and everyone else has a higher melting point than phosphorus. So it's chloride. How it's chloride can exist? Because they are saying that the chloride of Y and Z are white solids, right? So if we take any other white solid, right, and it's chloride, so it has a higher melting point than phosphorus. So that's why D is not the correct answer. Okay. So that's why D goes wrong. So we are left with A only. So A is our correct answer. So we'll keep the class till here for today. Tomorrow, no, not tomorrow. Now on Monday, we are going to continue from here onwards. Okay. So see you everyone in the next class. Till then, take care. Okay. Goodbye and Allah Hafiz.